First, some words about the desktop application architecture. You have different desktop software systems which rely on this desktop application architecture. For example, there's Microsoft Word. There are applications on your Windows platform, on your PC, on your Mac or whatever, and they basically rely on this application architecture. So the scenario in this architecture is that you have a piece of software which was somehow programmed and which was programmed such that it's deployed on one hardware platform only. It works alone and no interaction is required between other software artifacts. It's only this one very piece of software. A certain hardware platform can be your PC, your personal computer. It also can be your tablet, or it can be your smartphone. Looking at tablets or smartphone, it's kind of difficult to identify pure desktop applications because the tablet applications and the smartphone applications mostly have connections to centralized servers to synchronize some data, but there are also applications which follow this desktop application architecture only deployed on this hardware. Deployed on this hardware means that the entire software runs on one hardware only. There's no other hardware interacting with the software. And it also means that you need the appropriate storage which you need for operation of the program, for operation of the desktop software. So for example, if you have the Microsoft Word in mind, then you operate it on the Windows platform and you have enough storage to store your Word documents which you create with your Word program. And for just creating Word documents, you need no connection at all to the network. You can connect to the network for saving it on a network drive, for example, but it's not required to work with Word. You can work with Word even without any network connection. If you look in the development technologies, there are platform-specific languages. For example, if you think about a desktop application on Windows, you would use, for example, C++, you would use .NET technologies, or you could even use Java as the language for the platform-specific development. And this might be different from other platforms you would develop on. For example, if you would develop on Android, there are other technologies you would use, and they are sometimes not compatible with the technologies you use in PC and Windows-based applications. And an advantage in this case is that you do not need to deal with different platforms, with different technologies. You only rely on one technology you program in. You only rely on .NET, for example, if you want to develop a Windows software. Examples, as I said before, might be Microsoft Word, Microsoft Excel, applications which run on your desktop only without requiring any network connection. You could use dictionary applications, dictionary apps on tablets, for example, on smartphones. There are some dictionary apps which download with the application code also the entire dictionary. So then you need appropriate storage for a couple thousand of words. That's pretty enough on a smartphone or on a tablet, and you don't need to establish a network connection for a simple dictionary application. Another application would be a simple sketching application where you can draw some sketches on your tablet or on your PC, which only runs on this computer without a network connection and not based on a browser, but based on platform-specific technology. Next architecture pattern is the thin client architecture. And thin client means that you have one component shown here on the upper right side, one component which runs on one hardware, for example on a PC or in a tablet, and another part of the application is running on a central server. So what you do on your PC is, for example, you connect to a URL via your browser to access the application. The application might be browser-based, and then you have the GUI, the graphical user interface, available in your browser to input data, to visualize the data, and to somehow interact with the application program. In the backend of this application, backend is called this part which is below the graphical user interface. In the backend, you have some logic and you have some storage. And if you compare that to the architecture from the slide before, then you see that there is not only one of this rectangle with logic, but there are many of these rectangles. That means that the logic might be replicated depending on the demand of the users. If there are a lot of users, then there might be different logic components instantiated to serve all the needs from the users, to serve all the requirements, and to interact with the user and the storage appropriately. And also there might be the storage which is replicated again for managing the demand of the users. If there are many users connecting, then you have to replicate your storage to enable a proper function of your software. And what is important in this scenario is that you would use this application if you want to enable the users to access a centralized application, but from remote. So for example, if you imagine you have the Facebook platform, you know that Facebook is not installed directly on your PC or directly on your smartphone, but Facebook is running somewhere in the cloud, somewhere on centralized servers, and on these servers there's the logic and there's the storage. There is some storage for intermittent storing the data on your smartphone, but that's not the important part here. Important is that you have your remote client, which only consists of a GUI component on your tablet, on your PC, on your smartphone, and this is connected to a centralized server. And second important point in this scenario, you interact with data, you interact as a user with data on one central server. So there are different symbols for the storage here, but it's actually the same storage, the same data all users interact with. So it's one centralized data storage. If you design such an application, then in the GUI, in the graphical user interface, you have almost no logic in the graphical user interface, because you use the graphical user interface only for displaying the data, only for giving the user a view onto the data and for giving him a possibility to input some data. Both components, the central server and the GUI component, run distributed. That means the user can be somewhere very far from the central server and they are connected only via the interface. The interface here, if you look at the Facebook, the interface would be an HTTP connection via an Ethernet network, and via this interface the data are transferred from the central server into the GUI to show you the data, and if you input some data, then the data is transferred again via this interface into the logic, processed there and stored in the central server. In this application scenario with the thin client architecture, as I mentioned with this connection here, you are relying on a solid network connection. You cannot work with the GUI, with the Facebook GUI for example, without any connection. If you properly want to interact with the application, then you need the network connection. And that's why many people today ask about the Wi-Fi access. If they are abroad, they need the network connection to somehow interact with their social networks, with their applications maybe. Because a lot of applications use this application architecture where the storage operates centralized, the logic operates centralized, and the user only gets a very small component for his graphical user interface. An advantage in this application architecture is that with this architecture you can scale massively regarding the number of users. So the user doesn't need to install a big chunk of software. It doesn't require any large logic on the user side. The user only needs to download the graphical user interface, for example, as a web page, and then he can interact with the application. And on the server side, there is a certain mechanism to adapt the number of logic components according to the number of users. So if you have only a small amount of users accessing the application, then you have only a small amount of logic components here. And if you have more users connecting, for example, during special times of the day, there are more users connecting to Facebook, then you would replicate these components. You replicate them just to serve more users, just to serve more logic to the users requiring the application. And as one additional point, the storage in the logic here, which is modeled here on one central server, might also be divided on different servers. So maybe one server which hosts the logic only, and another server which hosts the storage only, to distinguish between storage and logic, and to use maybe a specialized server for storage or a specialized server for logic. If you look into the development technologies, then they are different from the technologies you would use for desktop applications. The technologies are very special for the platform you want to use. For the thin client architecture, you have technology, for example, for the graphical user interface, you would JavaScript, you would use HTML, maybe other desktop technologies. And on the server, you would use server technologies like Java, .NET, SQL as the access language into the database, and scripting language maybe also to support the application. Examples are, for example, Facebook, a very high scalable application. Another example is the university management system. You use it maybe every day. You look into your data, which is important for you, and you only access it via the browser. Or another example is the SAP software, SAP, which requires in certain scenarios an SAP GUI on the PC. You have to install it. It's kind of a framework for accessing the SAP system, but not much logic regarding the business logic. And finally, there's the distributed architecture. Distributed means distributed in a similar sense like the thin client architecture, but requiring more logic and maybe also storage on the side of the graphical user interface. So you somehow access data via the GUI, and then you have on your client side some logic, for example, logic for some simple processing. You have some storage, and you want to synchronize with the centralized logic with a centralized storage. One example would be Dropbox. You probably know Dropbox as an application which you can load on your PC, you can run it on your PC, and you can share your data, which you have locally on your PC. You can share it with a central server, and then you synchronize your data or parts of your data with this central server. storage application. And you can even synchronize it down to other PCs, to other devices like tablets or smartphones. And the thing is that Dropbox does not only work with a network connection, it works also without a network connection. Without a network connection, you can change your files, you can add more content to your files. It's not synchronized then, but you at least can work with these files. And later on, if you again connect to the network, then the logic on your PC and on the centralized server detects what changes were made in the time when the network connection did not exist. And the logic then resynchronizes your files, your local files, with the centralized stored files, such that you have one replication of your changes in the server as well. Again, looking into the development technologies shows that you have different technologies you might be using for such a distributed architecture. For example, if you develop a Dropbox application for a PC, then you would use desktop technologies like .NET on the PC, or for a browser-based client program which is able to process logic and to store some data, you would use JavaScript and HTML. On the server side, you could use other technologies like Java, maybe also .NET for the server programming, and SQL for accessing data, scripting languages to maybe support the logic on the central server. As I said before, Dropbox is one example, one simple example where you see that you can also work without network connection, but for proper operation the network connection is required, and the storage can work in times of lost connection without being connected to the centralized server.